Hello. This is a ferro photo of two magnets. This is sort of zoomed in because I have it on the floor and the camera's up a little bit. Here's a magnet here. This is an end of a magnet. That's the end of a magnet. That's that vortexy thing you see in a ferrocell. This is another magnet here with, of course, the vortexy things you see in the ferrocell. This is a ferro photo in a ferro cell light box, basically. And this bit in here and this bit in here is being forced into existence. I call this a monopole. This is a north pole, this is a north pole, this is a south pole, this is a south pole, and in between the two similar poles you get another pole being produced out in like free space, basically. These magnets are 1/2 inch apart, and this is the configuration I used. This is a little acrylic bit, so the magnets are like north, north, south, south, and I drilled a hole down through here so I can put a metal bar in it. God, come on, focus. To see if the metal bar becomes magnetic. Now, it's not going to prove anything, but at least I will demonstrate that. So anyways, as you can see, let me zoom back out. You can see how the ferro photo here acts, you know, pretty much like a ferro cell. It's of course not so clear because it's epoxy and ferrofluid mixed together, but you do get the same effect, right? So this is a solid piece. Of course, there's no magnets. So here, let me bring the camera up so I can focus over my table here. Now, see, these are pretty magnetic. Go away! Okay, so if I stick this in the hole, it should snap right to the center. Okay. The magnets are north, north, south, south, or vice versa. And that forces this thing to stay in the center. Now, what I say is there's a monopole here and a monopole here. So there should be a north monopole and a south monopole and a metal rod. Now, will this metal rod become magnetic? Well, let's see if I can bring this close. Oops, seems to be magnetic. Also, it's not magnetic. It's actually gained some magnetism since me playing with it. But if I, let's say, oh God, take this out. Please don't fly somewhere. And I put it in. Okay, that is. Now this is joining. Okay. So now the fields are north, south, north, south, or vice versa. And if I put this in here now, it is not quite the same. Where's my magnetic stick on? Oh, there's my. There doesn't seem to be much magnetism to this compared to the other way. There is no monopoles being produced here and here. There is a dielectric plane actually going down through there, because it's a north and a south and a north and a south, and you'll get one this way as well through the magnets. So this is not as powerful as the other way. Okay, stick it over there. And I only have one magnet, and the rod won't come out. Of course, it's being pulled towards the so there's a lot of friction now, because it's not being pulled the other way as well. So there seems to be some magnetic springiness at the ends. Now if I put that back in compression, or what I call compression, I'm really compressing the fields. Actually the magnets are in repulsion, but I call it compression because the fields are being compressed. You get quite the strong magnetic effect here. Now, is that due merely by the magnets, or is it also due to what I call these monopoles that exist here that you can't see, of course? I mean, that's pretty strong in comparison to the other one. This is very, So anyways, that's I don't know if that's evidence. It's just more thinking on my part. You have these, which let's stick it back in the box here. So basically, you see those monopole, what I call a monopole, in between the north and south, or sorry, the north and the north. And they look the same too. They have the same features, if not the same shape. You can see that the monopole I'm calling is dark in the middle. These poles on the magnets are dark in the middle, and they have light around them. So they not only do they look similar, and they act similar. When I view this ferrophoto with like one light source, like the ceiling light or something, the light rotates around that, and they rotate around that, so they act the same as well. So that's why I'm calling it a monopole. Does it make any sense? I don't know. But that's just my thoughts. Comment as you wish.